In this video, we're going to be discussing another multi-agent design pattern. And that's the skill pattern. That's the skills pattern. Skills. Now, ever seen a Swiss Army knife? Yeah, like the one you're looking at on the screen. This is a single tool. A single tool, but with different implementations. Different implementations. They all cut, but you can pull out any one of them based on what you want to cut. This is scissors-like. This looks like something with a jagged teeth, so any saw-like requirements. This is a perfect knife. This looks like a knife that can get into corners and make like deep cuts. This just looks like it can file nails and stuff like that. So it's a single tool, a knife. It even has a screwdriver here and another type of knife implementation here. A single tool with different skills. Just like if you have a fighter, their main responsibility is to fight, but they can punch, they can kick, they can probably like do a headbutt, do some acrobatics and stuff like that. Those are their skills. And that's what the skills multi-agent pattern is all about. It's a multi-agent architecture where a single agent, note, a single agent is a multi-agent architecture, but uses a single agent. A single agent dynamically loads specialized instructions and tools based on what the task at hand is about. Now, you might want to ask, isn't this like the hands-off pattern we did with the fancy create agent model that we were swapping prompts and tools? Isn't that the same? In a way, but a skills pattern is not trying to do some sort of sequential stuff. It's just performing a single task and finishing it. There's nothing like hand-off. You ask for one thing, it loads the skills for that thing, does it, and it's done. You ask for another thing, loads the skill to perform that thing, and it's done. So instead of having multiple separate agents, you have this one agent. I would call it a G.I. Joe. You have this one agent, and that agent can unlock different capabilities. Just like a fighter, if you need it to kick, it kicks. If it needs to kick, it will kick. If it needs to punch, it will punch. And all sort of stuff. So that is what the skills pattern is all about. But let us look at an analogy that is closer to something we can implement. Let's put our Swiss Army knife on one side. And let's say you have a skilled contractor. You hire a skilled contractor, a general contractor to renovate your house. Yeah, back to the renovation analogy. So you hire this general contractor to renovate your house. Now this contractor, Frank, I said this Frank. Let's get Frank on the screen. So here is Frank, who is a general contractor, and Frank is multi-talented. Frank went to technical school, he knows plumbing, he knows electrical work, he knows how to fix floors, he knows upholstery, he even knows how to do POP. So you have Frank, multi-skilled. This is Frank's knowledge base. Or let's say this is Frank's skill set. These are all the skill sets he got from school. He has plumbing knowledge. He has plumbing skills. Rather, Frank can also do electrical work. Frank also knows upholstery. So if you need to fix your chairs, if you need to fix the material on your chairs, yeah, he can do that. So Frank has all these skills. Plumbing, electricals, upholstery. Frank is so good. Or let's even call this generally carpentry. So these are Frank's skills. All these are Frank's skills. So you bring Frank to your house and you tell Frank, yeah, I need to fix some of the broken sockets in my house. I need to fix some of the broken sockets. I need to replace the power box. And I need to also install some lights outside. So what does Frank do? So this is you, the user, or the client, telling Frank that you need to do all those stuff. You need to replace the power box, you need to fix some broken switches, and you need to install lights outside. So what does Frank do after hearing those instructions? Frank is simply going to load in his electrical skills. Frank is going to load in his electrical skills. He's going to load them into memory and satisfy your query. He's going to get to work and he's going to do all that electrical work. Then once it's done, It gives you a response. It's done and you certify everything looks fine. You ask your back and forth questions, it makes his fixes and all that, all good. Then you tell him that you need some plumbing done. So what does Frank do? Frank immediately unloads the electrical skill, pick up the plumbing skill, and it loads it into memory. And then you guys can have a conversation about everything you want to do, and he's simply going to satisfy those requests. And it goes on and on. The same thing for the carpentry stuff or upholstery stuff. You want to fix your floors and all that. Even if you need to go back to electrical stuff, it will load in his electrical knowledge and satisfy those things. Then you need some plumbing done again. It's going to load his plumbing knowledge and satisfy those things. So he will be loading the skills on an as-needed basis. Frank will be loading the skills on an as-needed basis. The same person, just accessing different expertise as needed. That's how skills work. That's how the skills pattern works. One agent, multiple skill sets loaded on demand. But how does this work in terms of implementation? How does this work in the land graph context? So, first, your agent is going to have some base skills. And the base skills are basically going to be basic instructions. Probably Frank just has basic instructions about the structure of a house, how everything fits together. It just has those basic instructions. So there is a base instruction that comes with the agent. And also a skill discovery tool. So what I'm going to do now is that I'm just going to extend this. And let's put another box here. It's going to be transparent. And this will be a skill discovery tool. Discovery tool. So it comes with base instructions, just basic understanding. Then it comes with a skills discovery tool. Let's call it skills discovery tool. Yeah, skills discovery tool. Comes with a skills discovery tool. It comes with that. So a user then makes a request. So the agent, with its understanding, is going to call the skills discovery tool. It's going to take the user's instructions, use his base instructions, and the skill discovery tool to get all the skills. It then identifies which skill is relevant to the user's request. Let's say plumbing. Which skill is relevant to the user's request? Oh, it's plumbing. It then uses a function, let's say like a use skill function, to load in that plumbing skill. It loads in that plumbing skill, and it also loads in instructions, because these skill sets, they're basically composed, as we're going to see later, they're basically composed of instructions and tools. So it loads in instructions and tools and other contexts, retrieve data and all that for that particular skill. It loads it in, and they are injected into context. The agent then takes the skill, uses it to fulfill the query, and the skills will remain loaded for follow-up instructions. If the user needs to say any other thing, why is this power box here? Have you replaced all the fuse? There seems to be a broken connection here. This switch is not working properly. It just maintains it. It maintains the skill for follow-up questions. And later on, for other subsequent queries, you can always unload the skill and inject new skills based on subsequent specialized tasks that the user wants you to perform. By the way, let me get rid of this arrow so it's not confusing. So based on subsequent specialized tasks that the user wants you to perform, new skills can be loaded. Let me put some arrows here. I'm going to put a direct arrow for plumbing. Then let's put a dashed arrow for others. So you can show that, this can also be loaded in. So this is basically how the skills pattern works. You load skills on demand. Now, before we see some pseudocode to see how the implementation looks like in LangGraph, let us look at some key characteristics. I'm just going to put the characteristics up here. Say characteristics. And the first thing is that this is a single agent. It's a multi-agent system, but it uses a single agent because you have a single agent that shapeshifts. A single agent that shapeshifts. This is Mystique of X-Men. So a single agent gets to shapeshift. It handles everything by loading skills on demand. And I think the Anthropic team mentioned that that's how Claude Code works. And that's why you can also write skills and feed it into Claude Code. And even most of these other agentic tools nowadays, open code and the rest. I was tinkering around open code the other day. They all have skills. You can load skills and give the agent capabilities on demand. So single agent, that's the first thing. One agent handles everything. On-demand loading, we've talked about that. Skills are loaded on demand. Also, additive context. Additive context. Like I said, the agent comes with a base set of instructions and a skill discovery tool. Then you can add on to that. You can use that to know the tool to load the tool. So that adds to the context of the agent. So additive context. Skills add to. They don't replace. They add to the base instructions. Another thing is that you need a tool discovery system. There has to be a tool discovery system. Or more specifically, let us say skills discovery system. Skills discovery system. So the agent has to be able to discover available skills and select the appropriate ones. That's what this tool is meant for. It has to be able to select the appropriate skill for the job and also know which skills are available. Also, there is weak isolation because context is going to be added up. All skills are going to share the same context window. So you really don't get that clean isolation that patterns like sub-agents have. One good thing is that you have low overhead in terms of communication. Low communication overhead. You have low overhead. So you don't have multi-agent systems talking to each other. You don't have all those inter-agent communication. You don't have to build a whole communication bus for agents to communicate with one another. You don't have to report back to a particular agent. You don't have to do transfer and stuff like that. So there's low communication overhead. These are the characteristics of the skills pattern. Now let us look at how we can implement skills in LangGraph. We're going to be bringing our pseudocoder in once again to see how this skill system works in LangGraph. First, let us look at what comprises of a skill. What comprises of a skill? Let me see if I can highlight all this. Yeah, all this. Reduce it. Yeah, let's put it here. Oh yeah, skill sets. Yeah, skill sets. Yeah. So a skill comprises of three main things. Skill composition. Skill comprises of three main things. First, we have instructions. So when building up your skills, you have to provide instructions about the skill. What's it all about? What does it do? Then your skill has to have a set of tools. What are the tools that the skill is going to use to perform the actual actions it needs to perform? For example, a database skill needs to be able to execute SQL statements, list tables, describe tables, and stuff like that. That's important. Then you have to provide metadata for your skill. These are things like name of the skill, description of the skill, when to use the skill, and many more, and even other contexts that the skill would need. The metadata is where you stuff in all that information. So yeah, these are three core things that has to be in your skills package. Now let us look at the sample implementation using our pseudocoder. Sample implementation, get rid of this, is a new instance of pseudocoder. And the first thing you will need to do is define a bunch of skills. So here we have a skills constant, which is set to a dictionary, and it consists of two skills. The SQL query skill and the data visualization skill. These are the two skills we have in this example. Inside SQL query, we have a description, which is part of the metadata. We have instructions, which are, we've talked about, they are one of the core things that has to be there. Instructions, how the skill is to operate. You are now equipped to work with SQL databases, guidelines, always use parameterized queries to prevent SQL injection, limit results to 100 rows unless specified, explain query logic before executing. So they are kind of like sub-instructions within that can feed into a main instructions. They're like sub-instructions that can feed into that base overall instruction set. Then you have the tools. You have the tools that this skill can use. Execute SQL, list tables, describe table. These skills have to be available to the agent when you create it. So, same goes for the data visualization tool. You have the description, you have instructions, you have a set of tools that it can use. So once you have your skills defined, you can then define tools that are going to help you discover your skills and use them. So here we have get skills, and what it does is that it lists all the available skills and their descriptions. Whenever your agent is being prompted, this is going to be called. So it's going to check and see all the skills available to it. So you just give it a list of your skills And you can know, yeah, oh, I have this particular skill, I have this particular skill, I have the particular skill. And this person is requesting for a database operation, so I should be calling the database query skill. So it uses that to determine which skills are available. Then it then takes the skill it wants to use, calls this particular function. This function is a use skill function that you create so that it can take in a skill name and load the skill. Takes in a skill name and loads the skill. So with a skill name, you can go first check if that skill is available in your skill set. If not, you say that it's not available. If it's available, you get the skill, and then you can return the skill. You can return the skill into context. And then with these returned instructions, the agent will know that, yeah, I now have access to these instructions from this skill, and I have access to this skill. I have access to its instructions under these skill instructions, and I now have access to this list of tools, which it will definitely recognize from its tools list. That's the one that was provided to the agent upon creation. Now, sometimes you might want to add your skills dynamically. You don't want to provide all the skills at once to the agent when you define it. To do that, you can write a function like this. This is not formatting well in pseudocoder, so I'm just going to open another instance of it. So you can write a function like this. Write a function like this, which is going to be a middleware that is going to interject your model definition and be able to load skills on demand. So you can have all the skills defined as functions. You can have them all in a module file, all defined. So this way, you can write this type of function, inject skills tools. What it does is that it checks for loaded skills. It checks for loaded skills in state. This is a state variable that tracks all the skills that you've loaded. So you then check if your skill name is already in the skills that have been loaded. If so, then you also check if that skill name is in skills. You can extend it with the tools available in that skill name. And once you get those tools, you can then, first, you check if there's any tool at all. Then you take all the tools that are currently available to you, all the skills that are currently loaded, then you add the new skills to it. You add the new skills to it. You can then override your model definition by setting your tools property to this new all tools that has been updated with the tools that are coming from the new skill that you just loaded. Then always remember to return your handler with the request object. So this is how you can load your tools dynamically. If you don't want to load like 100 tools at the beginning because you have like, let's say 10 skills and each of them have 10 tools. If you don't want to load all those tools at the beginning, you can load them dynamically when you're actually loading the skill that has those tools. So yeah, that's how you can make your code cleaner by loading tools dynamically. Tools for your skills, you load them dynamically instead of loading them upfront. Now let's go back to our whiteboard and now let us look at benefits and trade-offs. Let's look at benefits and trade-offs. So here we have benefits and trade-offs here. So first, let us look at benefits. The first benefit is simplicity. Simplicity. You have just one agent. No inter-agent coordination, no communication bus, no hands-off and all that. You just have one agent, just loading skills. Just loading skills based on the user's request, based on what the user wants it to be. A shape-shifting agent. Secondly, we have low latency. Low latency. No routing overhead between agents. You don't have to move around like the sub-agents. You don't have to move around like handoffs. Single agent is managing everything and loading skills as necessary. Next is flexible composition. Flexible composition. You can simply load multiple skills simultaneously. So if you have a particular task that has it juggling around the knowledge base and tools of plumbing and electric work, you can load them, compose them together, and you don't need to do any complicated agentic gymnastics to get that to work. So yeah, that's another thing. Easy to extend, easy extension. Easy extension. This way, you can add new skills without restructuring. If you want it to be more powerful, if you want to give it newer capabilities, just add a new skill. Just add a new skill. And that's all. Just add a new skill. It will discover it by itself. It will use it as necessary. Yeah, easy to extend. Another thing is shared context. Just like handoffs, there's shared context. So all the skills can see the full conversation. So if they need to refer to anything, for example, the handyman that is doing both electricals and plumbing, these are things that can clash within the walls. So it knows, it has context. It knows that, yeah, I laid these pipes here for some wires. Definitely, I shouldn't have any kind of plumbing going close to it. So, yeah, shared context. Another thing is that there's a natural flow. There's a natural flow with the user. Everything seems like one conversation. Everything seems like one conversation. Unlike handoffs where you're like, yeah, I will now be transferring you to the marketing department, or yeah, I will now be transferring you to the technical department. This one just feels like a single conversation. It just feels like a single conversation. It's just one agent being a chameleon. There's no handoffs, so just basically feels like you're talking to the same guy. Also, it is cost efficient. It's cost efficient. You're using one agent, you're using one context window. You don't have to make multiple calls, make additional calls because you're trying to do communication. So yeah, it saves you on tokens. And finally, debugging trace is easier because it's single execution path to trace. Is a single execution path to trace. You don't have to trace multiple agents doing multiple things, and you're just tracing one single agent that is loading different capabilities. So yeah, those are the benefits. Now let's talk about trade-offs. First, we have the context window pressure. There's a lot of pressure on the context window to be very, very context aware, to be able to understand when it's to use plumbing, when it's to use electricals, when it's to combine both and everything. Loaded skills consume tokens and they mix a lot of information together. So you have to have a very intelligent model that knows how to do what is right when appropriate. Thank God models are getting smarter, but then you're still going to have to consume a lot of tokens because all the conversation history is being passed in. So context window pressure. Then we also have weak isolation. The plumbing work is not really separated from the electrical work, so a lot of that knowledge is coming and that can be confusing. Your skills must not have conflicting instructions. If your skills have instructions that overlap, if they overlap in a way that is conflicting, things are going to become very, very ugly. So that's another problem that you need to fix. Also, no parallelism. Yeah, your G.I. Joe handyman cannot do two things at once. Yeah, it cannot be doing electrical work and plumbing work at the same time. It cannot be doing them simultaneously. So you can't run skills simultaneously. Yeah, they can only feed off each other's context. When they're actually working, only one of them is being used. Also, you run the risk of having tool overload. You have the risk of running tool overload. We looked at the sub-agents pattern, and there we see that one of the main things is that it's able to help us split the tools. This guy does it too, but because everything is loaded additively into context, you have to have a very good unloading strategy to make sure that you don't load too many skills. You don't load too many skills and you don't load too many tools, because once you start having too many skills, you start having too many tools, and that will always lead to poor tool selection. So make sure that you have your unloading strategy in place. Next, prompt complexity. Base prompt is added onto the skills prompt. So you have to make sure that there's some sort of agreement between them. There's some sort of contract that you're maintaining. You have to always make sure that all the prompts get along. The base prompt, all the skills prompts, they must always get along. And even with that, this can start growing, and we know what too much context can cause to an agent. So that's always a problem that you have to keep in mind. Also, no specialization. It's just one dude that can do everything. And yeah, you can do your best to define your skills very, very well. But you can use different models. Of course, you might do the whole swapping of models thing. That's something you can do. But most of the time, you will be using the same model for all domains, and you might not be able to use specialized models for different types of tasks. So yeah, this is another caveat to using this design pattern for your multi-agent system. But I feel the model swapping middleware should be able to help in a way with this. But the problem is when you swap a particular model, you have to return all the context. So you probably are switching context window at that point, and yeah, that can come with its own complexity. So yeah, trade-offs and benefits. And I'm Resizing them now because it's time to talk about use cases. So those are your trade-offs and benefits. Know how to make your decisions. So now let us discuss use cases. Use cases. And the first use case that this is awesome for is coding assistants. Coding assistants. Like I've said, Cloud Code, Open Code. Yeah. This pattern is amazing for them. You can load specific language skills. You can load skills for Python. You can load skills for SQL. You can load skills for JavaScript. So the skills pattern shines a lot when you are using it for this type of agentic implementation. Another thing is knowledge bases. If you want to be multi-talented, you want to be a polyglot, and you need to switch knowledge bases, yep, you can use it to load different domain expertise on demand. Another thing is document processing. In document processing. Now, take note, when I say use cases, it doesn't mean that this pattern can only be used for this particular use case. It's just that it fits that particular use case. Sometimes it doesn't fit the overall use case. It fits a particular problem within that use case. So keep that in mind. Like, for example, in document processes, it's easy for you to load different skills to process different files. If you're going to be working with different types of files, you can load in different skills to work on different types of files. We also have data analysis. In data analysis, you can have different set of skills that you can combine. You can combine querying skills with visualization skills with interpretation skills. So you can load them in based on what the task you want to perform. If it needs 2 of those skills, you load it in. If you need 3 of those skills, you load it in. Then you just switch from one skill to another based on what you are doing at the moment. It will always use one skill every single time, but at least it makes it multi-talented and it can do different things. It can query, it can visualize, and it can also interpret. Also, writing assistants. Writing assistants. And in this use case, you can use it to load different tone skills. You can load a formal agent, you can load a casual agent, and you can load a very technical agent. So that's one of the things. If you're a writer, if you're writing a writing assistant, you can load different skills based on the type of tone you want to write the document in. Also in DevOps automation. Interesting. DevOps automation. Here you can have a DevOps agent, a DevOps multi-agent that can work on AWS, can also work on Azure, or work on GCP, Google Cloud Platform. So you can load in different skills based on where the client would like to host their resources or manage their resources, the cloud platform they choose to use. If you want AWS, you load your AWS skills. If you want Azure, you load your Azure skills. So those are the use cases, and that will be all on the skills pattern.